Hello dear students. In last classes we discussed about position vector, displacement vector, velocity vector and acceleration vector. Okay. So position vector ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್, ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ ಮತ್ತು acceleration vector ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ. And how to find their magnitude, how to find their directions. But in today's class we are going to discuss about the kinematic equations used in motion in a plane. Okay. Kinematic equations one dimension ದ ಸ್ಟಡಿ ಮಾಡಿದ್ರಿ ನೀವು. ಯಾವ್ಯಾವು? V is equal to U plus A into T. Then second kinematic equation S is equal to U into T plus 1 by 2 AT square. And third kinematic equation, what is that? V square is equal to U square plus 2 into A into S. ಹೌದಾ? ಇಲ್ಲಿ ಮೋಷನ್ ಇನ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಅಥವಾ ಮೋಷನ್ ಇನ್ ಎ ಒನ್ ಡೈಮೆನ್ಷನ್ದಾಗ ಒಂದೇ ಕಾಂಪೋನೆಂಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ನಾವು. ದಟ್ ಈಸ್ ಎಕ್ಸ್ ಕಾಂಪೋನೆಂಟ್ ಆರ್ ದಟ್ ಈಸ್ y component. But in case of motion in a plane, we are going to consider both components, x component and y component. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಫಸ್ಟ್ kinematic equation ಏನೈತ್ರಿ? That is v is equal to u plus a into t. Okay. In case of horizontal motion means it is a motion along the x-axis. Okay. Horizontal motion is an example for motion in a straight line or motion in one dimension. ಹೌದಾ? ಅವಾಗ ಏನು ಬರಿತೀವಿ ನಾವು? ಇಫ್ ದಿ ಮೋಷನ್ ಈಸ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ದಿ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಹಾರಿಜಾಂಟಲ್ ಮೋಷನ್. So in case of horizontal motion, how to write this kinematic equation? So here this equation can be written as Vx is equal to Ux plus Ax into t. What is Vx? Vx is nothing but it is the final velocity of the object along the x-axis in horizontal motion. What is Ux? Ux is nothing but initial velocity of the object along the x-axis. And what is Ax? It is acceleration of the object along the x-axis. And what is t here? T is nothing but time taken to change the velocity from initial to final along the x-axis. ಹೌದಾ? ಇದು ಹಾರಿಜಾಂಟಲ್ ಮೋಷನ್ ದಾಗ್ರಿ. ವಾಟ್ ಈಸ್ ಸೆಕೆಂಡ್ kinematic equation? ದಟ್ ಈಸ್ ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಇಂಟು ಟಿ ಪ್ಲಸ್ 1 by 2 AT ಸ್ಕ್ವೇರ್. ಆಲ್ರೆಡಿ ಇದ್ರ ಬಗ್ಗೆ ಕಲ್ತಿರಿ, ಹೌದಾ? ದೆನ್ ದಿ ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ಡ್ ಇನ್ ಹಾರಿಜಾಂಟಲ್ ಮೋಷನ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಪ್ರೆಸೆಂಟೆಡ್ ಬೈ ಎಕ್ಸ್. ಎದರಲ್ಲಿಂದ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀರಿ ನಾವು? ಎಕ್ಸ್. ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು then the velocity taken along the x-axis, initial velocity taken along the x-axis, that is ux into t plus the acceleration taken along the x-axis, that is 1 by 2 ax into t square. Okay, then it is a second kinematic equation used in case of horizontal motion. And what about third kinematic equation? That is v square is equal to u square plus 2 into a into s. ಹೌದಾ? ಹಾರಿಜಾಂಟಲ್ ಮೋಷನ್ದಾಗ್ರಿ ವಿ ನ ವಿ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರಿತೀವಿ, ಯು ನ ಯು ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರಿತೀವಿ, ಎ ಕ್ಯಾನ್ ಬಿ ಟೇಕನ್ ಆಸ್ ಎ ಎಕ್ಸ್ ಅಂಡ್ ಎಸ್ ಕ್ಯಾನ್ ಬಿ ಟೇಕನ್ ಆಸ್ ಎಕ್ಸ್ ಬಿಕಾಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ಡ್ ಇನ್ ಹಾರಿಜಾಂಟಲ್ ಮೋಷನ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಪ್ರೆಸೆಂಟೆಡ್ ಬೈ ಎಕ್ಸ್. ಹೌದಾ? ಇಲ್ಲಿ ನೋಡ್ರಿ, ವಿ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಯು ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2 into ax into x. So what this x? So ಇಲ್ಲಿ ಈ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಏನು ಮಾಡ್ತಂದ್ರಿ, ಮೋಷನ್ ಯಾವ ಎಕ್ಸಸ್ನಾಗ ಐತಂತ ಹೇಳ್ತಾರೆ. ಯಾವ ಎಕ್ಸಸ್ನಾಗ ಅದ್ರಿ ಮೋಷನ್ ಈಸ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್. ಸೊ ಮೋಷನ್ ಈಸ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್, ದಟ್ ಈಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಹಾರಿಜಾಂಟಲ್ ಮೋಷನ್. ಇನ್ ಸಿಮಿಲರ್ ಮ್ಯಾನರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ದಿ kinematic equations in vertical motion. ಅಲ್ಲಿ ವರ್ಟಿಕಲ್ ಮೋಷನ್ದಾಗ ಯಾವ ಕೋಆರ್ಡಿನೇಟ್ ತೊಗೊತೀವಿ ನಾವು? y ಕೋಆರ್ಡಿನೇಟ್ ಅನ್ನು ತೊಗೊತೀವಿ. ದೆನ್ ವಾಟ್ ಈಸ್ ದಿ ಫಸ್ಟ್ kinematic equation used in case of vertical motion? So that is Vy is equal to Uy plus Ay into t. Is it right? So Vy means it is a final velocity taken along the y axis. Uy means it is a initial velocity taken along the y axis. Ay means it is the acceleration of the object along the y axis. Okay, ಇದು ಯಾವ ಮೋಷನ್ದಾಗ್ರಿ? ಇದು ಇಟ್ ಈಸ್ ಇನ್ ಕೇಸ್ ಆಫ್ ವರ್ಟಿಕಲ್ ಮೋಷನ್. ಹೌದಾ? ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಪ್ಲೇನ್, ಇನ್ ಕೇಸ್ ಆಫ್ ಮೋಷನ್ ಇನ್ ಎ ಪ್ಲೇನ್, here we are going to consider two coordinates x and y. But in case of motion in one dimension or motion in a straight line, we are going to consider only one coordinate. That coordinate may be x coordinate or that coordinate may be y coordinate. ಹೌದಾ? But in today's class we are going to discuss about the kinematic equations used for the motion of a particle in a plane. See here, kinematic equations. Kinematic equations in two dimension or in a plane. In two dimension or in a plane. So after these kinematic equations, we will solve some problems related to the kinematic equations in case of plane or in case of two dimension. See here, what is first kinematic equation? That is V is equal to vector V is equal to vector U plus vector A into T. ಹೌದಾ? But in case of one dimension, we are going to consider only one direction. That may be forward direction, that may be backward direction, or that may be upward direction, or that may be downward direction. But in case of motion in a plane, we are going to consider x and y both directions. ಹೌದಾ? ಅದರ ಸಂಬಂಧ ನಾವು ವೆಕ್ಟರ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ತಗೊಂತೀನಿ. So vector V is equal to vector U plus vector A into T. Then vector V can be resolved into how many components in a plane? So vector V ಅಂದ್ರೆ ಇಲ್ಲಿ final velocity vector ಆಗುತ್ತೆ. ಹೌದಾ? So the final velocity vector can be resolved into how many components? Two components. What are those? X component and y component. I will write vector V as Vx into unit vector I. So what its meaning? So its meaning is the x component of final velocity vector, okay, plus the y component of final velocity vector, that is equal to, and also initial velocity vector can be resolved into how many components? Two components, because we are going to study about motion in a plane, okay. Then that is Ux into I plus Uy into J. ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ ಎರಡು ಕಾಂಪೋನೆಂಟ್ ಆಗಿ ರೆಸಾಲ್ವ್ ಆಗಿರುತ್ತೆ. ಫೈನಲ್ ವೆಲಾಸಿಟಿ ವೆಕ್ಟರ್ ಎಷ್ಟು ಕಾಂಪೋನೆಂಟ್ ಆಗಿ ರೆಸಾಲ್ವ್ ಆಗಿರುತ್ತೆ? ಇಲ್ಲಿ ಎರಡು ಕಾಂಪೋನೆಂಟ್ ಆಗಿ ರೆಸಾಲ್ವ್ ಆಗಿರುತ್ತೆ. ಸೊ ಎಕ್ಸೆಲರೇಷನ್ ಆಲ್ಸೋ ರೆಸಾಲ್ವ್ಡ್ ಇಂಟು ಹೌ ಮೆನಿ ಕಾಂಪೋನೆಂಟ್ಸ್? ಟೂ ಕಾಂಪೋನೆಂಟ್ಸ್. ಒನ್ ಈಸ್ ಎಕ್ಸ್ ಕಾಂಪೋನೆಂಟ್, ಅನದರ್ ಒನ್ ಈಸ್ y component. I will write vector A can be written as Ax into unit vector I plus Ay into unit vector J. Then into time t. Because time is a scalar quantity. Time is scalar quantity. ಅದ್ರ ಮೇಲೆ ಏರೋ ಮಾರ್ಕ್ ಹಾಕೋಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ಯಾವ್ಯಾವ ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟೀಸ್ ಇರ್ತಾವೆ ಅವ್ರ ಮೇಲೆ ಅಷ್ಟೇ ಏರೋ ಮಾರ್ಕ್ ಹಾಕೋಬೇಕು. ಓಕೆ, ಸಿ ಹಿಯರ್. ಸೊ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಈಸ್ Vxi, Vyj. So it is a final velocity vector in a plane. Okay. Then initial velocity vector in a plane Uxi plus Uyj. Then I will multiply this bracket with the t. T ಲಿಂದ ಈ ಬ್ರಾಕೆಟ್ ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬೋದು. So that will gives plus into plus Ax into t unit vector I and Ay into t unit vector J. Ay into t unit vector J. See here in right hand side, so I will take I as common here. In these two, what is common? I is common. Then if we are going to take I is common in these two, then in bracket we will write Ux plus Ax into t. Then what is common here? I is common. Again multiply this bracket with I, you will get Uxi plus Ax into t I. Okay, then plus in these two terms what is common? J is common. Then I will write Uy plus Ay into t. Ay into t, it is unit vector J. Then it is Vxi plus Vyj. Then we are going to find the final velocity along the x-axis, and also we are going to find the final velocity along the y-axis. Okay, so on comparing the coefficients of unit vectors here, then ith coefficient vx ಅದರಲ್ಲಿ ಇಲ್ಲಿ ith coefficient ಏನಾದ್ರೆ ux plus ax into t comparison. Then so vx is equal to, from this equation we are going to write vx is equal to ux plus ax into t. Is it right? And it is the taken along the x-axis. It is the equation of motion taken along the x-axis. And vy is equal to uy plus ay into t. uy plus ay into t. It is the equation of motion taken along the y-axis. ಎರಡು ತಗೋಬೇಕಾಗತ್ತೆ ನಾವಿಲ್ಲಿ. In case of motion in a plane, we are going to take the final velocity along the x-axis and also the final velocity along the y-axis. Okay, this is about the first kinematic equation. Then what about the second kinematic equation? So that is displacement vector is equal to initial velocity vector into time plus 1 by 2 acceleration vector into time square. Here. Second kinematic equation, that is displacement vector delta r. In case of plane, the displacement vector is represented by delta r. That is equal to initial velocity vector into time plus 1 by 2 acceleration vector into time square. Okay, then now what is a displacement vector? So it is a final position vector minus initial position vector. So I will take the final position vector as r and initial position vector as r naught. So r naught ಅನ್ನೋದು ಏನಂದ್ರೆ it is the position vector of the particle at the time 0. Okay, then r is nothing but it is a position vector of the particle at the time t. Here the position vector is changed from r naught to r because the particle is moving in a plane. Edra move aagtadri, that is moving in a plane. Plane means 2 dimension. Then r minus of r naught is equal to u into t plus 1 by 2 at square. Then what are the components of r and what are the components of r naught? R the components ಏನೇನಾಗಿರ್ತಾವ್ರಿ x and y. So it is the position of the object along the x-axis and also the position of the object along the y-axis. I will write xi plus yj minus r naught ಅನ್ನು ಹೆಂಗೆ ಬರೀತೀವಿ ನಾವು? The x naught I plus y naught j. R naught can be resolved into two components, x naught and y naught. R can be resolved into two components, x and y. Okay, it is the final position of the object along the x-axis and it is the initial position of the object along the x-axis. And what is y? Final position of the object along the y-axis. And what is y naught? Initial position of the object along the y-axis. Remember, ನೆನಪಿಟ್ಟುಕೊಳ್ಳ್ರಿ. So that is equal to u can be resolved into again two components, x and y. So that is uxi uyj into t plus a can be resolved into again two components, 1 by 2 axi ayj into t square. Okay, then see here I will multiply this bracket with the negative sign. Then we will get xi plus yj. Then minus into plus minus x naught I minus into plus minus y naught j. That is equal to, I will multiply this bracket with the t. Then ux into t I and uy into t j. Then next here I will multiply this bracket with 1 by 2 t square. 1 by 2 t square in the multiply matter. Then we will get 1 by 2 ax t square into unit vector I plus 1 by 2 ay into t square into unit vector j. Okay, then see here, in these two I is common, then x minus of x naught into unit vector I. In these two what is common? J is common na? Then I will write y minus of y naught into unit vector j, into unit vector j. Then that is equal to, in these two ಇವೆರಡಕ್ರಾಗ ಏನು ಕಾಮನ್ ಅದ್ರಿ? ಐ ಕಾಮನ್ ಅದ್ರಿ. ಓಕೆ, ಸಿ ಹಿಯರ್ ಯು ಎಕ್ಸ್ ಟಿ ಪ್ಲಸ್ 1 by 2 ax t square into unit vector I. Then in these two what is common? J is common, plus so ui into t plus 1 by 2 ay t square into unit vector j. See here, on the comparison from left hand side and right hand side, what we got? So x minus of x naught is equal to, ಸೊ ಐದು ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಅದೇ ಥರ ಜೆ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡ್ಕೊಳ್ರಿ. ಓಕೆ, ಸೊ ಐ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? ಎಕ್ಸ್ ಮೈನಸ್ ಆಫ್ ಎಕ್ಸ್ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಎಕ್ಸ್ ಟಿ ಪ್ಲಸ್ 1 by 2 ಎ ಎಕ್ಸ್ ಇಂಟು ಟಿ ಸ್ಕ್ವಯರ್. ಸೊ ದಿಸ್ ಗಿವ್ಸ್ ದಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ದಿ ಆಬ್ಜೆಕ್ಟ್ ಅಲಾಂಗ್ ದಿ ಎಕ್ಸ್ ಎಕ್ಸಸ್. ಎಕ್ಸ್ ಮೈನಸ್ ಆಫ್ ಎಕ್ಸ್ ನಾಟ್ ಅದ್ರಿ ಫೈನಲ್ ಪೊಸಿಷನ್ ಮೈನಸ್ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್, ದಟ್ ಗಿವ್ಸ್ ದಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಎಕ್ಸಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಏನಾಗತ್ತೆ ರೀ? ಜೆ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡ್ಕೊಡ್ರಿ. ವೈ ಮೈನಸ್ ಆಫ್ ವೈ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಐ ಟಿ ಪ್ಲಸ್ 1 by 2 ಎ ವೈ ಇಂಟು ಟಿ ಸ್ಕ್ವಯರ್. ಸೊ ದಿಸ್ ಒನ್ ಗಿವ್ಸ್ ದಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ದಿ ಆಬ್ಜೆಕ್ಟ್ ಅಲಾಂಗ್ ದಿ ವೈ ಆಕ್ಸಿಸ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಮೋಷನ್ ಇನ್ ಎ ಪ್ಲೇನ್ದಾಗ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ನಾಗೂ ಇರುತ್ತೆ, ಅದೇ ಥರ ವೈ ಆಕ್ಸಿಸ್ನಾಗೂ ಇರುತ್ತೆ. ಇಫ್ ವಿ ನೋ ದಿ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ, ಇಫ್ ವಿ ನೋ ದಿ acceleration, we can find the displacement along x and also displacement along y. So this is about the kinematic equations used in 2 dimensions. Just remember this formula. Okay.